Welcome back to the STM32 CubeIDE Getting Started series. This is Bryce from 2026. So I had originally made this video series to use in my class, my embedded systems class, where we use CubeIDE to create projects for the STM32 and specifically for the L432. It turns out that in the fall of 2025, ST made a change to CubeIDE that where they removed CubeMX, the project generator, from the tool. And so it had always, prior to I can't remember the exact date, but at one point they were two separate tools, and then they integrated them into one thing, and that turned out, I think, internally to ST to cause some problems with development schedules. CubeMX is a code generator that has to be aware of all their new parts and small variation changes to their parts, and so it's got a lot higher change velocity than the IDE itself, which is relatively stable. And so I think that was causing development problems for them to get those two things integrated. So they've separated them. And so my videos, especially video 2 in this series, leaned on the fact that CubeIDE was built in. But now they're two separate tools. So I wanted to create a video. So it's causing some of my students some problems getting going. The fact that these are two separate tools. And so let's look at what that takes to make that work. All right. So if I come over here, you're going to download a couple of tools. It's not just one tool anymore. It's two tools. There's CubeIDE, which you can go and download, and it works for all the major platforms. And so we've had pretty good success here on Windows, Linux, and Macs. People are able to get it to work on any of those platforms. And then you're also, along with CubeIDE, you're going to need to download CubeMX. You'll have a second tool here. This second tool is the one that is, like I said, is new. Again, it works on all. These are Java-based tools, so they'll work on pretty much any machine, and so at least Windows, Mac, and Linux. So, okay. So I'm assuming you can go off and get those installed. May have to download some packages when you're generating. Especially, when we do this for the first time, you won't necessarily see that when I do it, but your system will have to go out and get the L432 libraries if you follow along here. All right, so the first step here, what we're going to do is, let me come back to me here. What we're going to do is we're going to fire up CubeMX, and we're going to go and we're going to create a template project. That's where we're gonna start working in that template project. All right, so if I come over here, I'm going to come to another screen now. I've already booted CubeIDE and CubeMX. You don't need CubeIDE running at this point, but you will later. So this is really about CubeMX right now. And so I've already booted those. They take a few seconds to boot here. They don't come up real quick. So I didn't want to hassle the video with that time. So let me bring this up here. So when you come in, it will look something along these lines. You'll have different projects and stuff. But anyway, it'll basically look like this. And again, what this tool is, what its purpose in life is to configure software. So as I tell my students, back in the old days of embedded systems, you had to write libraries, for the particular peripherals that were part of your design that you needed in these embedded machines. It was tedious, it was error prone, and embedded engineers spent a lot of time in data sheets trying to sort out, how to make the peripheral work. So as a sort of competitive advantage, vendors, the STs of the world, TI, they started producing peripheral libraries. And so these tools are really about helping you leverage their software stack to get your application going faster, right? You can use their libraries. Okay. So what I'm going to do is I'm going to go to this access the board selector, because we're using a specific board here. We're using the Nucleo L432. If you were doing your own custom board, where you had, you were just putting a bare processor on a board, and you were gonna build your own project, you would go and just choose the particular processor you're using, and then you can configure it from there. Now, when you're using it, when you're configuring for a board, some of the decisions about, what's hooked up, for instance, in our case, where's the LED hooked up? Where is the UART? Which pins did they choose for that? Because they've already used, the processors being, or the microcontrollers being used in that design. So you've got to know what pins they've already chosen. So we're going to use the board selector here. Like I said, it is not the fastest tool in the world, but I found it's pretty effective. And so we're going to type in, L432, and it will bring up this L432KC. They're pretty good. My experience is I've never gotten a Nucleo board or a Discovery board from ST where I was not able to find the board in here. They're pretty good at keeping this up to date. Before they release a board to the public, they make sure it's in here. So we'll choose this one here, and then we're going to start a project with that particular processor. And I generally just initialize all of them to the default mode. You can do other things if you, let's say you're using Nucleo board in a larger system. You've got it, you're building maybe it's a larger software prototype where maybe this is sitting on some sort of interposer board where you're actually using the Nucleo in an early prototype. You might have some of those peripherals already defined, and you want to just go ahead and make sure. But if you're just using the bare Nucleo board like we are, we use it in sort of this configuration here. If we're just using it like that, just take the defaults. All right, it is creating this thing called an IOC file, and that is a file that's going to keep our configurations. And so, in this, we can select these pins, and again, down the road, we may, let's say, we want more than we want to use some timer. In the case of our design, we're going to use a timer. You choose a timer here, and then you can choose the pins that go with it. Each one of these pins, you can click on them and choose the function. So it's a pretty, again, coming from the old days of doing embedded systems, I tell my students that's my, walking uphill barefooted in the snow sort of a story for them. They'll obviously be able to tell their students one day, or their kids, that they remember a time when we didn't have AI to help us. And so mine is we didn't have these libraries to help these systems along in the early stages. You had to deal with it. All right. So here you are. You've got this, and again, in the other videos, if you were to watch it, you'd be like, hey, that's exactly what I saw when I created a project when it was in CubeIDE. That is exactly right. This exact same Java code. It just happened to be integrated before. All right, so it's not integrated now. Here we are. You've got some ways of bringing in some of their firmware packs. Those can be very useful, especially if you've got a discovery board where it's got other parts on there. So discovery boards typically have more other, maybe they've got a display, or maybe they've got an external memory. They've got something, they've got other stuff, and sometimes these software packs can be really nice, or you want to do something unique, some communication peripheral. It's really handy to go in there and grab, some starter software to kind of get you bootstrapped. Anyway, so the clock configuration is, if you don't know this about embedded systems, you will learn that as you work with them, that the clock trees are highly configurable. There's a lot of things that you might want to do. Not to say that a larger processor's clock tree is any less sophisticated. I think in the embedded world, it's just more configurable because there's more things that you might want to do to optimize your system. And so, all right, so we'll come over to the project manager. That's really where we want to spend our time. And we can give this a name. I'm going to call this, getting, I'll just call it getting started video. You call it what you want to call it. That's just what I'm calling it here. And I'm going to put it on, I'm going to put it out in this, you can put it wherever you'd like. It doesn't really matter. You can, it's going to, when you import this into CubeIDE, it's going to add a it's going to add a file to help you navigate to it when you get into CubeIDE. So it doesn't really matter. And for my students out there, I would recommend you putting this in your class GitHub repository, wherever that is. You know, I keep my GitHub repositories in this directory I call Forge. You know, you can put them wherever you want, but I would just find that GitHub repository and plop it in there. It'll make things easier down the road. Anyway, so yeah, so I'm just going to put this on my desktop here just to make it easy for me to find it here. I'll just put it out on my desktop. Yep, it's okay. And so it's going to do this. The advanced application structure is fine. You want to change the tool chain. These are various different ways of interacting with the tool. I'm going to just use the CubeIDE one. And so yeah, it'll generate the necessary the necessary, I think it's an XML file, basically the project file that when you import this into CubeIDE to recognize that, hey, this is a CubeIDE project, and so it's already pretty much set up for that. You can do other things. You can tell it where the firmware's at. Again, if this is the first time you're doing this, it's going to download some firmware, the firmware that you need for this particular processor, right? So it doesn't. I mean, if it were to bring in all the firmware for every project, you know, your disk footprint would be enormous. So it doesn't do that. It just brings in the processors that you use, and there, you know, when you can tell it which one. You know, you can keep you know, there's ways to configure CubeMX to bring in the processor libraries that you care about. Over time, it'll as you load things up, it'll check to make sure they're current and go out and grab the latest one. All right, so once you've got this, you just say generate code, and it's going to go out and it's going to take those libraries, and in fact, it's pruning them. It's only putting the stuff you need, depending upon how you configure it. I think here it'll ask you whether you want to. Oh, maybe not. Maybe it's not. In the code generator section here of this, it will tell you. It'll ask you, hey, do you want to generate? Do you want to bring in all the libraries, or do you just want to bring in the ones you're actually using? You know, and so you can configure that. So, yeah. So we'll let that cook here for just a second. It is copying them. It takes a minute here to get that in. Kind of unfortunate for the video. Yep, there it is. And so, you know, we can open this folder. Here, I'll try to figure out where it's going to pop open here. This is what it looks like. You know, and again, you know, it's got, you know, your C files here under core, and then the drivers are things like, you know, all the HAL drivers for things like hardware abstraction layer. HAL stands for hardware abstraction layer, and so it brings in things like, you know, for the UART, right? All the calls that you need, and yeah. And I don't know if in SimSys stuff, what does it have in here? Yeah, I guess it's not. The SimSys stuff is basically a way of it's ARM Cortex interface standard that basically allows allows vendors to produce things that are standard. So if you're bouncing between RTOSes, as long as you're using SimSys compliant things, you should be able to move between the different processors without changing your OS code. That's the idea. And so, you know, kind of as you're working at that higher level of abstraction. All right, so now we've got that. We've got this piece, and effectively, at least for the near term, we're done with CubeMX. You know, we don't need any more now that we've generated that project. So I'm gonna close this down or minimize it here. And here's my here's CubeIDE. It's one with CubeIDE in it. And so CubeIDE, without going into too much detail, it's a pretty standard editor. It's based on Eclipse. In the old days, you know, you would have to kind of configure Eclipse, set it up. Nowadays, they distribute it as kind of a whole thing that includes all of the compilers and debugging tools that you need. So it's integrated. And so for getting started at this sort of doing embedded development at this sort of low level, I think it's a really nice way to go. Nowadays, being 2026, a lot of people want to use VS Code, and so ST is supporting that. But the installation and the getting started is a little bit more challenging. So for that reason, that's why I don't use it in class. I'm trying to get all of my students to get this installed on their laptop, personal laptop. It's too challenging if that, with the different configurations, if they have to install the tools themselves. So we use CubeIDE for that purpose. Okay, so what we're going to do now is going to do file, import existing projects into the workspace. And then we'll go browse to the desktop here. Desktop, and go into here, select that folder. And it'll find that project, okay? And so I'm not gonna go into it here. I'm gonna suggest that you can go and look this up on your own. I don't know necessarily, but there are these things called working sets. I have a lot of little projects in my Project Explorer, and so it will really pollute this area over here. You'll see zillions of projects. So I'm going to add this project to a group, just to a group is a way to thin down that. So I'm going to come over here and I'm going to add this to a working set. And I created a working set earlier. Let's see if it'll show me. Here's my working sets. Can't remember what I called it. I'm just going to throw it in with one of this timer video series, because I've already got that up over here. Say okay. And so when I do a finish, it's going to bring that project in, and then it will show up underneath this. Here's my getting started video project. And so I'm going to go ahead and close this main. Every C program's got a main. So that's from another project. So I'm going to come in here and I'm going to start navigating through this. Here's all my includes. Here's my core, and the core is going to have, it's going to, under core source, you're going to have main, and depending upon, in the L432, it's not that big a deal, but you might see some more complex architectures that get generated, where you've got maybe an application, and you've got some other pieces, in some of the more complex processors, like we use the WB55 here, where it's got an M4 and an M0 together. So this may be a little different in a more complex processor than the L432, which is just a Cortex M4. So I'm going to load this main here, and this is where you're at. So now you can start playing the game, so to speak. So now you're ready to go. And so in a subsequent video, we'll talk about how you modify this, how you talk to the board, and so that we're going to use this little debug thing here, not the run, but the debug. So we're going to debug by basically compiling this down to an ELF file, and then sending this across something called an ST link, which is a piece of software, and it's also the name of the debugging hardware that's on the Nucleo board. Just to kind of foreshadow this a little bit, on the back side of this board, there's a debugger that, it's actually another ST processor that is talking to the ETM, embedded test measurement interface, on the L432, which is sort of the back door into the processor that lets us do things, basically we can drive that, it's built into the Cortex M series processors, but it allows us to drive the processor, load registers, talk to memory, those sorts of things. That allows us to load the program in there. Well, anyway, that whole chain of ST-Link tools, debugging tools, then basically at the top end exports a GDB interface that allows us to debug it here right from Eclipse. And so that's how we're going to get the code down on the processor. All right, so I think again, grab this stuff from ST. I think you still have to register. You may have to register an account. It's no big deal. I haven't found that they bombard me with stuff. You'll get to the point where you've got the code here. You know, again, they broke these tools apart. Now it's no longer just CubeIDE. It's no longer just CubeIDE with CubeMX integrated. They're two separate tools, which I think in the end is what people want. And frankly, with the direction being more and more people in the ST ecosystem, just from what I've read, are moving to the VS Code, and I've used that interface. It's pretty good, especially obviously you get all the power of the editing power of VS Code, which I think is a little bit lacking in the Eclipse universe or the CubeIDE universe. But sort of the debugging integration inside of CubeIDE is hard to beat. And so I would say for now, depends on what your focus is, and and people use these hybrid development approaches where they're using both. Yeah, so for students, it's just simpler, I think, to stick with CubeIDE for now. But I think that's why they forked the tools. They broke the tools apart for that purpose, so that it was a little easier to keep things more stable in CubeIDE, but also to maybe better support the folks that are in the VS Code ecosystem. All right, okay, so that's it for this video.